Okay, hey everybody, this video is going to be about multiple representations, which is something pretty new, and you should have watched the graphing video to kind of review about the coordinate plane. So here we go. In multiple representations, it's just different ways to represent data. You're going to have verbal representations where it's written in words. You have your equations, which is like 2x plus 4 mat equal y, and then you're going to have a table representation and a graph. So that's why it's multiple representations, because you're going to have to do it multiple in various ways. So let's look at A. A is going to be a chart where you have some x's and you have some y's, and you have to determine that relationship. So a lot of times we just ask you to find the rate of change. Basically, how is x changing and how is in correlation or relationship to y. So I always start, just x and y. You could choose your side. So let's say here, what is my rate of change? How am I getting from 2 to 4? I'm adding 2. From 4 to 6, I'm adding 2. 6 to 8, adding 2. 8 to 10, adding 2. Now from 50 to 35, I'm subtracting 15. 35 to 20, subtracting 15. 20 to 5, subtracting 15. 5 to negative 10, subtracting 15. So my rate of change is basically my change in my y over my change in x, and that triangle is going to mean change. Now, my change in y is negative 15. So every time my y decreases by 15, my x is going to increase by 2. So my rate of change would be my y is going to decrease by 15 as my x increases by 2. So let's look at the next table, B. And let's start here. My x going from 1 to 4, I'm adding 3. 4 to 7, I'm adding 3. 7 to 10, I'm adding 3. Then my y, 1 to 16, I'm adding 15. 16 to 49, I'm adding 33. And 49 to 100, I'm adding 51. Here, here my x increased by 3, but my y went up 15. And here, my x went up 3, and then my y went up 33. There's not a constant rate of change. Every time it was different. So this is what we call a nonlinear relationship. And you can tell in linear, you see the word line. That means when we graph it, it wouldn't be a straight line. So let's try this next one. From 3 to 4, you're adding 1. 4 to 5, you're adding 1. 5 to 6, you're adding 1. 6 to 8, you're adding 2. 8 to 10, you're adding 2. 10 to 12, you're adding 2. So your change in y, and then your change in x, well, as y increases by 2, x is going to increase by 1. So we talked about this one being nonlinear. So which table represents a linear relationship? A would represent a linear relationship, and C would, because it had the constant rate of change. And basically, as y went up, or as y decreased by 15, x went up by 2. And over here, we had a constant rate of change. Every time the y increased by 2, the x increased by 1. Or you could say every time the x increased by 1, the y increased by 2. Which table represents a proportional relationship? So now this is a little bit different. You got to look at the table a different way. Proportional, you have to say, okay, what am I going to multiply 2 by to get to 50? That's times 25. Am I going to be multiplying by that same number all the way down? Are they proportionally related? Now, another way you could say is, okay, 50 over 2, is that equal to 35 over 4, 20 over 6, 5 over 8? And are they equal proportions? No, 50 over 2 is not equal to 35 over 4. And you could do the same thing here. What am I multiplying 1 by to get to 1? I'm multiplying by 1. Is that going to be true here? No, because here you're multiplying 4 by 4 to get to 16. Here, 7 times 7 to get to 49, and so on. It's a different multiplier. Let's look here. 3 times what is 6? Times 2. 4 times what is 8? Times 2. 5 times what is 10? Times 2. 6 times what is 12? Times 2. So C would be proportional because all the points are proportional. You could have 6 over 3, and that's equal to 8 over 4, which is equal to 10 over 5, which is equal to 12 over 6. All of these are equal to 2 over 1. Non-proportional relationship would be A and B. Please don't freak out. We will be working on this in class, so please, please, please don't freak out. This is just a preview, if you will. So now let's talk about those multiple representations. So let's go how we're going to go from equations to charts to graphs. So basically you're going to have to use your knowledge about equations. So here we go. We have y is equal to 2 times x plus 1. And you're going to use that equation to form ordered pairs to graph it on the graph. So let's say if x was 0, we do 2 times 0 plus 1. 2 times 0 is 0 plus 1 would be 1. So your ordered pair would be 0, 1. Let's say we wanted x to be 1. We put a 1 in for x. 2 times 1 plus 1. 2 times 1 is 2, plus 1 would be 3. And then our ordered pair would be 1, 3. Now let's say our ordered pair was 4. 2 times 4 plus 1. 2 times 4 is 8, plus 1 is 9.49. Let's say we wanted to do 3 now. 2 times 3 is 6, plus 1 be 7, 3, 7. Now, I used my equation to make a chart, and from that chart, I was able to gather points to graph. So let's say 0, 1, start at the origin, go over 0, go up 1, 1, 3, go over 1, up 1, 2, 3, 4, 9, go over 1, 2, 3, 4, up 9, 1, 2, 3, 4, 5, 7, 8, 9. And then 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And you can see it's going to make a line. Okay? So let's do a couple on the, I don't want the video to be too long, so let's do a couple on the next two charts. So let's say y is equal to x minus 3. X is 0. You put 0 in place of x. 0 minus 3 would be negative 3. So your point would be 0, negative 3. Let's say it was 3. Your x is 3. 3 minus 3 would be 0. So your point would be 3, 0. Let's say x was 5. Where am I getting these x's from? Just in my head. So 5 minus 3 would be 2. So you'd have an ordered pair of 5, 2. And then let's say it was negative 4. Well, negative 4 minus 3 would be negative 7. So negative 4, negative 7. And I could then use these 4 points to make a line. Or I can even see if it makes a line, because sometimes it won't make a line and you have to prove it. So let's do 2 points on this last one. Negative 3 times x. So x is 0. Negative 3 times 0. Y would be 0. Be 0, 0, which is also the origin. Then 1, 2, and 3. Negative 3 times 1 would be negative 3. Negative 3 times 2 would be negative 6. Negative 3 times 3 would be negative 9. Now, what you want to realize, finish filling this in, if it goes through the origin, see this one right here goes through the origin, this one that we just graphed right here did not go through the origin. If it goes through the origin, it's going to be proportional. If it does not go through the origin, it's going to be non-proportional. And we will go over more of this in class. We will do lots and lots of examples, and I will push you and you will love it. So, that is all we have for this video.